So this is the atomic structure and periodic table review sheet. Again, it's just a really good way to test your revision. If you've missed certain parts, you can have a quick look through. So starting us off, we're going to go back through the structure of an atom. So the first question is, what three particles make up an atom? And that's proton, neutron and electron. Draw and label an atom. So the neutrons and the protons are in the nucleus, and then the electrons orbit in the shell. Really important thing to notice is that in an atom you'll always have the same number of protons and electrons. If you've got different number of protons and electrons, that is an ion, not an atom. Moving along then to a little bit of a table again, just an overall structure of an atom. So it's asking you to name them: proton, electron, neutron, give their charge. So protons are positive, neutrons are neutral, and then electrons are negative. The mass of them, okay, so protons weigh about 1, neutrons the same, weigh about 1, and then electrons weigh 1/2000. Okay, so they're very small. Most of the mass is in the is in the nucleus, where the protons and the neutrons are kept. The electrons then orbit around in the shells. Moving on then to a little bit of information on the periodic table. So what does the atomic number tell you? The atomic number in the periodic table, so the smaller number, tells you the number of protons. And then you need to remember that protons and electrons are always the same in atoms. What does the mass number tell you? The mass number is the massive number, and that tells you the number of protons and neutrons. Describe what an isotope is. Same atomic number, but a different mass number. So they have the same number of protons, but they have a different number of neutrons. Next thing then, where do electrons orbit? In the shells. So electrons orbit around the atom in the shells. The nucleus in the shells. What is the configuration of the first 4 shells? That's all you need to know up to. So only 2 electrons can fit in the first shell, 8 in the next one, 8 and then 8. Draw and write the electron configuration for sodium. So sodium has got an atomic number of 11. So that means it's got 11 protons and 11 neutrons. So you'll put 2 in your first shell, 8 in your second shell, and then 1 in your final shell. Looking at the outer shell, that means it's in group 1, and it's got 1, 2, 3 shells, so it's in period 3. Nitrogen then has got the atomic number 7, so it's got 7 protons and 7 electrons. So 2 in the first shell, then 5 in the next shell, so it's in group 5 and it's in period 2. The outer shell tells you the number of the group, and how many shells there is tells you the period. Moving then up to a little bit more information about the periodic table. So the groups go along the top and then the periods go down. A really important thing to notice is that in group 1 you've got hydrogen and helium. In period 1 you've got hydrogen and helium. Okay, period 1 does start there, it doesn't start 1 below, which is a really common mistake to make. I've then highlighted in blue the diatomic molecules, which means the molecules that exist in pairs. So you've got hydrogen, nitrogen, oxygen, and then all of group 7. The period is the number of shells, and the electrons is the number in the outer shell. Going on then, you'll be asked to describe the information you know about 3 different groups. You've got group 0, group 7 and group 1. So I'm just going to quickly go through some of the questions or some of the answers that you might need to know. The first thing you might be asked is to describe them. So describe group 0, unreactive, diatomic, which means they all exist in a pair, less dense than in air, so helium and neon. And then list the uses. Helium is used in balloons, neon is used in lights, and argon is used in light bulbs. Moving on then to group 7. So group 7 is fluorine, chlorine, bromine, iodine and acetine. Describe fluorine, chlorine, bromine and iodine. So they're the top 4. Fluorine is the top one. Fluorine and chlorine are gases. Fluorine is is a yellowy gas. Chlorine is a greeny gas. Bromine is a red-brown liquid, and then iodine is a dark grey solid. Reactivity with ions. They all react with iron to form like iron halides we call them, so it's iron mixed with group 7. Reactivity decreases down the group. Fluorine is at the top of the group, it's the most reactive and requires the least heat. Reaction with halogens, so the more reactive halogen will displace the less reactive halogen. So if you had magnesium chloride and fluorine came along, it would then become magnesium fluoride and chlorine would be left on its own. How do you identify them? So you have something called silver nitrate, you add something called nitric acid first, chlorine will go white, bromine will go yellow, and bromine will go cream and iodine will go yellow. Finally then, group 1. So group 1, there's just the 3 top elements, lithium, sodium, potassium. List their properties. They are very reactive in air and water, so they will float. They have low densities. They're very easily cut, which makes them a little bit different from other metals. Reactions with oxygen tarnish to form a metal oxide, speed up down the group. Same with halogens, form a metal halide. So there's an example, sodium bromide. More reactive halogen will displace the less reactive halogen. And then you've got your flame test colours at the bottom, which you really need to remember. The most important thing to remember from this side of the review sheet is that with group 1, reactivity increases down the group, but then with group 7, reactivity decreases down the group. Okay, you've got to remember the difference. Even if you just remember the one, you know that the other one is the other way around.